So this one's covering Unit 2B, solving problems with units. So kind of the first thing you're going to do is you're going to identify the units in the problem and the units you expect from the answer. Okay. Then you're going to use the given units and the expected units to find a strategy. And when you complete your calculations, make sure the answer has the units you expect. The other thing to make sure the answer is something that's expected. Okay, so for this class, we're going to use things, that make sense in the real world. So if it doesn't make sense, if your answer doesn't make sense, then you probably did something wrong. And if the units don't make sense, then you've definitely done something wrong. For example, a car travels 25 miles every half hour. How fast is it going? So cars are usually measured in miles per hour. So we're going to go 25 miles, 0.5 hours, divide it, and we get 50 miles per hour. For example 2, we're buying 30 acres of farmland at $12,000 per acre. What's the total cost? So we have 30 acres. We have $12,000 per acre. Remember, per means divide. The acres cancel. 30 times 12,000 is $360,000 for the acres. Number 3, we're going to buy pesto. We're making pesto. We need to buy basil. If I go to the grocery store, I can buy 2/3 of an ounce for $2.99. If I go to the farmer's market, they're going to sell me a bunch at $12 per pound. Which is the better deal? So we're going to start out at $2.99 for 2/3 of an ounce. And that means we're going to pay, if I divide those, remember per means divide, we're going to end up with $4.49 per ounce. Well, the farmer's market was selling it per pound. So we're going to set up a unit conversion, 16 ounces in 1 pound. The ounces cancel, and if we multiply the 4.485 by 16, it is going to cost $71.76 per pound. So the farmer's market is a better deal per pound. The car gets 27 miles per gallon. How much does it cost to drive 115 miles when gasoline is $2.75 per gallon? So 115 miles, we can get 27 miles per gallon, so the miles cancel. And we are just left with gallons, so it's going to take 4.26 gallons to make the trip. Well, if it costs $2.75 per gallon, we multiply, and it's going to cost $11.71 to make the trip. Number 5, suppose 2018, 956,250 people died of a disease. The country has 305 million people. What is the mortality rate in deaths per 100,000? So a lot of times when we deal with things like death and crime and disease, they'll give you a number per 100,000 because you would expect that areas with more people would have more cases and areas with fewer people would have fewer cases in terms of total number. But sometimes you want to know, is the rate comparable? Okay. Or does the large area have not only a larger number, but a higher percentage or rate per 100,000? It's possible, though, that a small town, if a few people get something, that can force the rates per 100,000 to go up. So you kind of want to look at both cases. You need to look at total numbers, and you also need to look at percentages or rates per 100,000. So in this case, there was 956,250 deaths. So that we want to know deaths per person. So we're going to divide that by the 305 million. And that gives us 0.003 deaths for one person. But we want to know deaths per 100,000, so we're going to times that by 100,000. And there was some decimals after the 3, so when I kept the same answer multiplied by 100,000, we got 313.5 deaths per 100,000 people. The follow-up question was, what's the number of deaths per minute? So we have 956,250 deaths per year. We need to convert year to minutes. So 1 year, it's 365 days. So years in the numerator, days is in the denominator. Years cancel. We're going to convert days to hours. So day goes to the numerator, 24 hours goes to the denominator. Days cancel. Convert hours to minutes. So hours cancel and we have 60 minutes, and then we're just going to multiply and divide, and you would get 1 death, or 1.82 deaths per minute. All right, does it make sense or doesn't make sense? Someone can run 15 liters per second. Well, liters is a volume, and we run in lengths or distance, so this does not make sense. You could drink 15 liters per second theoretically. The swimming pool could fill at 15 liters per second, but you cannot run at 15 liters per second. So here are some other ones that don't make sense. Sorry, you're not allowed to join Yahoo Answers. You got to be at least 13 years old. It's only 14 years left. That means this person has not been born. We Hate Math says 4 in 10. Majority of Americans. Yeah, not quite. The average American averages 27 hours of TV a day. That's a fact. And it was 7 pounds. That's the British sign for pounds. However, it's now half price. It is now $7.35. Go ahead and enjoy. I can buy one for $4.69 or £4.69, or I can buy 2 for 10. 4-piece nuggets, 1 for $1.19, 10-piece for $1.49, or I can get 20 pieces for almost $5. Same little lighter. I can get a pack of 1 for 88 cents, or I can buy a 2-pack for $4.99. I'm going to save $12 when it goes on clearance from $52.99 to $47.99. Once again, always make sure it makes sense, such as buying a used book for $35, or I can buy it new for $1.7 million. It does have a 93% positive rating though. Not sure if that makes it worth it. It is $899. We're going to take $400 off, and you'll just pay $628. Please join Planet Fitness at $10 per month, or we'll throw in a deal and you can pay for 18 months for $199. Once again, always check your answer to make sure it makes sense. Or you can go with this. 99-cent plaza. Everything is 99 cents or less or up. I think we're covered. All right, energy. Energy is what makes matter move or heat up. Okay. So energy is really just how much it takes to raise the temperature of something, usually in water. Okay, so if you've probably heard about calories, a calorie is the amount of energy it takes to raise 1 gram of water 1 degree Celsius. So there's other ones. There's a joule, and power is the rate at which energy is used. So the international metric unit is what? Not is watt. It is watt, W-A-T-T. And a watt is 1 joule per second. So if you get your electric bill, a lot of times on there you'll see kilowatts and joules and gives you a measurement. What it's telling you is how much energy you used and how quickly you used it. So a kilowatt hour is 3.6 million joules. Okay, so you may see kilowatts on there, you may see kilowatt hours on your electric bill. Okay. So if you want, at your apartment or your house or wherever you are, you can actually find the electric meter outside somewhere, and you can watch it spin, and what it's doing is it's telling you the watts that you're using as it spins. And then if it moves a little too quickly, you go inside and shut a bunch of things off to try to slow it down. Density describes the compactness or the crowding. So material density is how much something weighs, okay, usually in grams per cubic centimeters. Water is 1 gram per cubic centimeter, so if it's less than 1 gram per cubic centimeter, it will float on water. If it's more than 1 gram, it'll sink. Kind of your random fact for the day. The planet Saturn is the only planet whose density is less than 1. So if you could find a large enough water source, Saturn as a planet would actually float on water. So the other gas planets would sink, but Saturn actually would float. Population density is the number of people per unit area, usually square miles or square kilometers. Information density is how much memory can be stored on digital media. Yes, memory does take up space. Okay, so if you're going to store something, it does actually take up physical space. So a square inch of a dual layer Blu-ray can hold 1 gigabyte of information. So a disk has an information density of 1 gigabyte per square inch. All right. Just for some reference point, there's your population density of places around the world. The darker the color, the more dense it is. And there's a population density map for the U.S. Okay, once again, the darker the area, the more dense the state is in population. All right, Manhattan has 1.6 million people living on it. It is about 57 square kilometers. What is the population density? So we're going to take 1.6 million people. We're going to divide it by 57 square kilometers. And you get about 28,070 people per square kilometer. So, kind of give you a reference point, the main campus at Pitt, from Vernon White over to Russells and Williams, probably that area. It's probably about a square kilometer. So imagine 28,000 people living on Pitt campus. It gives you an idea of how dense Manhattan Island is. Concentrations. Okay, it's the amount of one substance in with another. So medical dosage is usually done per body weight, and then will be done per milliliter. Okay, so that's why they tell you not to take somebody else's medicine, because your body weight, their body weight are probably going to be different, and you'll have different dosages. Okay. Also, if you have underlying conditions, it will also affect the dosage. Blood alcohol content describes the concentration of alcohol in a person's blood. It is grams of alcohol per 100 milliliters of blood. So for most places, your blood alcohol content is 0.08. In other words, you would have 0.08 grams of alcohol per 100 milliliters of blood. If you're over that, you're drunk driving. If you're under that, you're technically legal. All right, so for number 8, we have a child weighing 15 kilograms, so about 30 pounds, with an ear infection. We're going to give them amoxicillin, and we're going to do 30 milligrams per kilogram of body weight. This is why when you go to the doctor, they always take your weight in kilograms. So we're going to divide the doses into 12 hours. How much amoxicillin should be prescribed every 12 hours? So we have a 15 kilogram child. We are going to have 30 milligrams per 1 kilogram. So we're going to combine those kilograms canceled. And we need to take 450 milligrams of amoxicillin per day. But the question asked how many every 12 hours. So we're going to divide that in half and take 225 milligrams per 12 hours. Okay. Once again, when you are writing these down, make sure you give me a unit. So milligrams per day, milligrams for 12 hours. It also kind of helps keep track of how, when you're working through the problem, what you've done, and then where also you need to go. All right, last question. I don't really like this one, but it is on your homework, so we're going to go ahead and go through it. So it says the average man has 5 liters of blood, so 5,000 milliliters. Average 12-ounce can of beer contains 15 grams of alcohol if the beer is 6% alcohol by volume. If, and this is the part I don't like, if all the alcohol was immediately absorbed into the bloodstream, what would the blood alcohol content be? Okay, that does not happen. Your body does not absorb all of the alcohol, and it definitely does not absorb it all at once. But since it is on your homework, we'll go ahead and do it just so you have a reference. So 15 grams of alcohol in 5,000 milliliters gave us 0.003 grams per milliliter. Well, if you remember, blood alcohol content was per 100 milliliters. So we're going to times by 100. And that gives us a 0.3 BAC. If your blood alcohol content is 0.3, you're probably in a coma or passed out and very close to blood alcohol poisoning. Okay. So, like I said, this one is not very realistic because your body doesn't absorb all of it that quickly, but we're going to go with it. So, second question, how much beer would make him legally intoxicated? So, legal is 0.08, so 0.08 divided by 100 means he can have 0.0008 grams. He has 5,000 milliliters of blood, which means he can absorb at most 4 grams of alcohol. And if there was 15 grams in 12 ounces, which can set a proportion, multiply, divide, he can have 3.2 ounces of beer, and that would make him legally drunk.